Let's understand about shuffle. So what is a shuffle? Shuffle is movement of data between partitions or executors so rows with the same key are brought together. Let's check the next slide. So imagine you have a Spark job and you give a query uh, containing a group by statement on departments. So as part of the Spark job, imagine this is the driver. So the driver has requested our cluster manager to create 3 executors. So once you submit your Spark job, the job will be divided into three among these 3 executors. And let's say this 1, 2, 3, these records belong to partition 1. These 3 records 4, 5, 6 belong to partition 2, and this third one belongs to partition 3. As we know, each partition will be processed by each executor. Let's say P1 went to executor 1, P2 went to executor 2, and P3 went to executor 3. So I can write here. So now when you want to group by department, so as we can see, few of the departments are in partition 1 for IT and some in executor 2. Since they are in different executors, what the Spark needs to do, it needs to send this data across the networks or across the executors to perform the group by. So that movement is called shuffling. Now after movement, we'll have something like this. If you see here, before we had IT and HR in executor 1, in executor 2, and HR and IT finance in executor 3. But after shuffling, what we'll have the same type of records in executor 1. So if it have to group by using IT key, then executor 1 will contain the IT records, executor 2 will contain the HR, and this executor 3 will contain finance records. So once this shuffling has been done, then the Spark can easily do the group by. So this is how shuffling is done, and it is required to perform few operations. Now why shuffle is expensive and why data engineers need to avoid it as much as possible. So network transfer. The data transfer across the networks consumes compute and time. Same for disk, serialization and CPU. We can see it consumes a lot of resources. Now the question is, what if executor cannot hold all IT data? Imagine this executor 1 is having 4 GB of RAM and 8 GB of hard disk, and we have a billion rows, and the data size is somewhat around 15 GB of data. So some part of this data will be stored in this RAM, some will be spilled to this hard disk. Storing of the data in hard disk is known as spilling. So how the Spark will execute? It will first execute this 4 GB of data, and this 8 GB of data will remain in queue. Once this 4 GB of data is processed, then the Spark will bring some data from this 8 GB and it will continue to process those as well. So this concept in Spark is known as spilling. And what if your total data set size exceeds this 12 GB? As we can see in this executor 1, we have 15 GB of IT department. So here 3 GB is extra, which cannot be stored in RAM or in hard disk. So this 3 GB will give us error. So what is that error? We may get disk full, task failure, or out of memory error. Executor will restart and task will be retried again.